This is Well Seeker Pro training that will cover the functionality of the Directional Drilling Dashboard. The Directional Drilling Dashboard is one interface designed to encapsulate an awful lot of data useful whilst drilling. That data is a 3D plot, a tool face rows, real-time anti-collision, real-time projections, drilling parameters both in the form of a real-time graph and also in drillers' gauges. With all that functionality on one user interface, it makes it extremely useful for directional drillers in the field and also for personnel in real-time operations centres, as it gives them a very quick overview of what's going on a single screen for each well that they're drilling. In order to use the Directional Drilling Dashboard to its full capability, you should have in place an actual wellbore. Within the actual wellbore, you should have an updated and complete BHA within the drill string editor. You should have all of your actual wellbore properties filled in correctly. You should have a survey, and that survey should have all of the relevant offset wells included, including your principal plan. For that given survey, you will need to access the slide sheet. The user must input up-to-date slide sheet information or have it populated in real time by WITS data using the auto-populate slide sheet function when hooked up to WITS or WITS-ML data. That's covered in a separate training, so if you need to find out how WITS and WITS-ML work, please go and reference that training video. If the user is using WITS or WITS-ML data, they also need to verify that the rig states information is getting calculated correctly. This will dictate whether the slide sheet is being updated and also the rig state will be displaying correctly in the Directional Driller's dashboard. Once you have all those things in place and all of the offset wells have been verified that their settings are correct for running with anti-collision, you can then go ahead and open up the Directional Drilling Dashboard. That can either be taken from the toolbar with this DD dashboard icon or go to Tools, Directional Driller's Dashboard. This opens up the Directional Driller's Dashboard and immediately you get a settings window open. I'm going to close that for now and we'll cover that in more detail later. This is the default layout. We have rig gauges which populate based upon real-time WITS data on the left here. We have a tool face rows. We have a 3D plot. We have surveys and projections as well as real-time anti-collision, and we have a drilling parameters chart. We can change the layout of the Directional Drilling Dashboard by going to Settings and unchecking or checking various options. This frees up more space for things that you might be more interested in. Note that it's possible to have more than one Directional Drilling Dashboard open at any given time for the same well. However, this will create an additional drain upon your hardware. So bear in mind the specs of your computer that you're running on if you want to run multiple windows of this. I now have a scenario where we've got WITS or WITS-ML data being pulled into the Directional Driller's Dashboard. And as we can see, our rig gauges are updating, with the exception of RPM and torque because we're currently sliding. And our drilling parameters section on the bottom right here is also updating based upon the WITS information and some information from our rig states dialog and from the drill string editor. I'm now going to go through the individual sections one by one. The rig gauges are where we'll start off. So these are the simplest. These are purely a graphical output of the WITS data that's coming directly in. And when I say the WITS data coming directly in, is this current WITS data section in the rig state settings. We can see the physical last WITS or WITS-ML data points that have come through. So that's what's getting updated here in real time. You can edit what's displayed on these gauges by going to Settings, Gauge Settings. And in here you can choose what mnemonic from your WITS or WITS-ML is being pulled into those gauges. And you can also set a min and max range for that gauge. And that is simply the rig gauges. Next section we'll look at is the drilling parameters section. Again, this is purely made up of widths values that have been pulled in. The survey and gamma offsets come directly from your drill string editor MWD component details section. The rig state comes from your rig state setting dialog. The effective tool face and slide grade come from your real-time width slide tool face information. Hole size comes from your drill string editor, as well as the bit type and bit hydraulics information. Your bottom hole temperature also comes in from width. The chart here is by default made up of differential pressure, flow rate, hook load, ROP, weight on bit, pump pressure, and RPM. And each of these traces can be seen independently on the chart itself. You can change the range for each of these series by going to Settings, Set Drilling Parameter Ranges. And this will give you your min and max values in the chart for each of the individual series. Now we'll go ahead and look at the 3D plot. And this 3D plot is very similar to the main user interface 3D plot. However, there are a couple of differences here. The work site is the same. Offsets and actual well bores are depicted in red. Plans are depicted in blue. In this case, this is our principal plan on the right. Our actual well bore here in the centre. And we've got an offset well here, another red well over there. We also have pink lines and yellow lines from that point onwards. The pink lines depict an advisory projection. The yellow lines depict a project ahead of 100 and 200 foot respectively, and green line indicates a bit projection. Each of these blue points either relates to a survey point or a critical point on this listing here. So we've got our surveys, bit projection, 100, 200 or advisory. And as you can see, based upon the widths data, our measured depth and coordinates for our bit projection are updating in real time. And this is based off of our slide sheet. So based upon what our slide sheet is reading, whether that be incoming from widths or whether the user has input this manually, that will update our bit projection in real time. That will be reflected in the 3D plot, and it will also be indicated within our toolface rows section and projections section. If your slide sheet hasn't been updated and your last survey depth plus your survey offset is greater than your last survey end depth, then the bit projection will be based upon your survey depth plus your projection depth, whichever is deeper. Okay, within the 3D plot section, again, much like in the standard 3D plot, we can go up in between these individual points, and that will update the coordinates and our up, down, left, right, center to center distance from plan information. Moving on to our toolface rows section. In here we have a target area, the center of which is our principal plan, bang in the center. So if your actual well is bang on the center, then you're bang on your principal plan. This green dot here is our bit projection location in relation to the principal plan. The two squares are our 100 and 200 foot projections respectively, and the pink or magenta square is our advisory projection at 100 foot. This additional green dot here is our offset well. The red circle here is a maximum radius distance in this particular vertical mode, And you can see here we've got radius of 10, 20, 30, 40, 50 foot, which auto scales based upon distances involved. The 0 to 360 degree range refers to either a magnetic or a high side bearing, depending on the type of tool face that we are receiving at the time. So in this case we've got a magnetic tool face coming in, so this is related to north at 0. We also get a bright green line, and that is our slide recommendation if that's turned on, currently on a 144 magnetic tool face. Blue dots represent real-time WITS tool face values, and then you'll see just here there's a darker, fainter green, and that is our effective tool face. We also have in the center here, this value is the most up-to-date tool face value that we got in text. The information in the top left of the tool face rows will vary depending on which mode we have selected. We can see our bit projection, measure depth, inclination, azimuth, our two further projections beyond the bit projection at 100 and 200 foot intervals, or our advisory projection based upon a 100 foot projection beyond bit. We've then got our mode setting, tool face to plan, what our slide is, rotary dogleg severity, rotary tool face, our planned incanazi, our delta incanazi from the plan value based upon our current bit projection, and distance to the next critical point on the principal plan, and the recommendation of what we do now in our current state. In the section at the bottom here, we have our surveys, bit projection, additional projections beyond the bit projection at 100 and 200 foot respectively, and then if it's turned on, our advisory projection at 100 foot distance, as well with all the depth, inclination, azimuth, TVD, up, down, left, right, dogleg severity values. We also have a anti-collision setup here, where we've got at the top our principal plan information, and then any offsets that we have selected or are within range. So we have the name, reference depth, center to center distance, separation factor, reference ellipse, offset ellipse, ellipse separation, and any warnings that might occur. And that very quickly is the overview of the Directional Driller's dashboard. I'm now going to stop the WITS input, and we're going to go over some of the settings for these individually. If we go to settings, we can choose the number of tool faces that consecutively display on the tool face rows before they're hidden. So in this case I've got the maximum number selected as 10. Show offsets on the rosebud. If I uncheck this, our offset well will not be displayed. Set drilling parameter ranges we've already covered. That affects the chart for the drilling parameters, each series min and max values. We'll come on to settings in a moment. Check for warnings. We will also cover that when we go to settings. Gauge settings we've covered. We've already covered how to toggle on and off the various different sections of the DD dashboard. If you go into the 3D chart settings, this is where you can choose things to view or not view. So we can turn off lease line curtains, well names, compass ring, work sites. Okay, so all the individual components can be turned off. And then view, this allows us to go straight to the daily report section, for example, or the slide sheet, or the survey sheet, or a slide advisory history straight away. So the biggest outstanding thing that we still need to cover are the settings. The Directional Drilling Dashboard settings are where you select your mode. And depending on the mode, that will affect what is displayed in the Directional Driller's Dashboard sections. It won't affect your rig gauges or drilling parameters, but it will affect what projections are displayed in the projection setting, what projections are displayed on your 3D plot, and information in the top left and main body of your tool face rows. To access your settings, either go to Settings and Settings from here, or double left click anywhere on the Directional Driller's dashboard. This opens up your DD Dashboard Settings dialog. So what does our DD Dashboard Settings dialog actually do? It deals with a number of inputs and options, that affect our warnings, our projections, and our slide advisories, or our directional advisories. Those are the three things that are affected within the settings in this dialog. First thing to note is you've got 5 modes here: no mode, vertical mode, nudge mode, curve mode, and lateral mode. No mode means that you effectively don't calculate any additionals beyond the default within the DD dashboard. Vertical mode is what you'd select when you're in a vertical portion of the well. Nudge mode is currently in development. Curve mode is what you would select when in the curved portion of a well. And lateral mode is what you would select when you're in the lateral portion of a well, or potentially a tangent section. In addition to the mode selection checkboxes, you'll also notice some other checkboxes and some other cells to be input with values. The importance of these will vary based upon the mode that you currently have selected, and we'll go through these when we're looking at the individual modes. The top section here for landing target is only important during your curve mode, so we will cover that during the curve mode discussion, and the section at the bottom here is the warnings section. The warnings, again, vary between different modes, but universally, even with no mode selected, a warning criteria will pop up based upon drilling parameters, but only when receiving WITS data. So right now we're not receiving any WITS data, and so it's not looking for any warnings based upon drilling parameters. However, when we do have WITS data turned on, it will take the maximum values you've got in the component properties for your motor and input them here. So I'll go ahead now and start transmitting WITS data, and we'll see the drilling parameter warnings populate in this part of the dialog. Okay, we can now see that we've got 3 warnings: max RPM, max differential pressure, and max flow. As I said, all populated from the motor component properties inputs within the drill string editor. Our current value on WITS is 0 for RPM and differential pressure and flow, so we're not approaching the threshold. But what you'll see is that as we approach the threshold, we will get orange and red warnings. Orange meaning that we're still below but approaching the threshold, and red meaning that we've exceeded that threshold. So we'll go ahead and simulate that now. You can see here we've got an RPM of approximately 120, and that is close enough to the threshold to trigger our orange warning, close to maximum RPM. If we minimize this, we can also see the main dialog of the DD dashboard is flashing orange, indicating that a warning of orange nature has been triggered. So even when this settings dialog is closed, you'll still get the warnings populate. If you try and close the settings warning whilst an alarm is triggered, it will keep opening up. The way to get around that is to suppress the warning message. If you suppress the warning, you'll stop having a flashing screen. You can also close the settings dialog, but the user has to manually suppress this warning. Next, we're going to look at the red warning, and that is in a scenario where the value that is set is exceeded. So we're going closer to 160 RPM now. The max RPM has been exceeded, and you can now see we have red error warnings flashing on the DD dashboard, and it's indicated as a red warning in our settings dialog. Again, this can be suppressed by checking the suppress box. That will allow you to close the settings, but this is the alarm system for drilling parameters. Okay, our RPM value has dropped down below the threshold. You can then uncheck the suppression checkbox, and a timer will indicate how long that threshold was exceeded for. Based upon those times exceeding, you can then go to File, Print Warnings Report, and this will create an Excel document detailing all of the warning messages that we've had in that part of the dialog, what the threshold was, the time above that threshold. Okay, so obviously I've used this database for multiple different tests before, and I've got some other warning messages that we haven't covered just there that have accumulated over time. So this is a way of keeping a good idea of the time you spent above certain drilling parameter thresholds, and with the other drilling modes, some of the other thresholds. So now that we've looked at the settings dialog as a whole, what checkboxes actually affect no mode? Well, to answer that question, what does no mode entail? No mode entails just taking our surveys and providing a projection to the bit. So how does a projection to the bit work? Well, we can see here that our last survey was at 530 foot. Our bit projection is at 600 foot. Now, if we look in here, we've got a survey offset of 67 foot. If we add that onto 530, that would be 597 foot. So it's obviously not taking it from the survey plus the survey offset. It's taking it from somewhere else in terms of the depth. And where it's taking it from is our slide sheet. So what the software does is it looks at the state that you have between your last survey point and your bit projection point, i.e. 600 foot. And we can see here that we have rotation as the state of our drilling between the survey point and our bit projection. So based upon that, the software is going to do a rotary projection to bit. By a rotary projection to bit, I mean it will either use a straight line or a rotary dogleg severity rotary tool face projection based upon some settings I'm about to discuss very shortly. If, however, we had a slide state selected with a tool face and distance of slide given, it would then be a projection based upon a sliding interval. And that would then use some of the settings input within the settings dialog to calculate based upon the motor yield and the slide distance a bit projection, which would realistically cover that slide scenario. So that is how a bit projection is generated. Okay, so the first one we come to here is include rotary in projection. If I check that box, we'll see that my projection to bit has actually changed from 1.01 inch to 1.49. Okay, if I uncheck it again, we'll see we've got a straight line projection to the bit. So what is this actually doing? If we have include rotary in projection, it's taking the information for the rotary dogleg severity and the rotary tool face from these cells and utilizing that information to make a projection based upon actual values that we have input here, as opposed to just a straight line projection. So if you want a straight line projection to bit, you uncheck this box. If you want to use actual numbers in your projection to bit, include rotary in projection. Another option that's selectable in no mode is slide advisory. Now, I would never recommend turning this on with no mode, because the whole point of no mode is that it has no specific logic to determine how to steer in this particular portion of the well. If we turn on the slide advisory, it will provide a slide advisory, but it will most likely not be suitable for the particular section of the well that you are drilling. So I would not use slide advisory within a no mode selection. Limit anti-collision display. So down here we've got our anti-collision display, and right now we can see 3 offset wells and our plan, and we can see 2 of our offset wells are very close centre to centre distance wise, and one of them is reasonably far away, 55 foot. If we check the limit anti-collision display option, we now see that we're down to 2 actual wells and 1 planned well bore. And what this does is it will only display the wells that are a close enough anti-collision risk. So in this case we've got 2 actual well bores of a very close centre to centre distance. That third well was deemed far enough away in terms of centre to centre distance and separation factor to not be displayed in the real-time anti-collision. Auto pick curve target is only relevant in curve mode, so we'll discuss that later. The auto motor yield and auto rotary functions do not function when no mode is selected. Landing TVD, landing inc, landing ASI are all related to the curve mode. Rotary dogleg severity and rotary toolface, as pointed out, are utilised, whatever's input here, in the include rotary and projection checkboxes activated. So for example, if I change this to 1.5, you'll see that the bit projection updates based upon what is in input in these two cells. But only when this include rotary and projection is checked. If I uncheck it, it's a straight line projection, as already discussed. So that's what it uses to make that projection. Motor yield is also used if there is a projection based upon a slide interval in your slide sheet. The default motor yield is the yield that will be used until a motor yield is calculated. Again, this motor yield does not get calculated in no mode and will be covered later. Max, vertical inc, delta inc, and delta ASI are all not used in no mode. Same for these, everything in this column, and the top 4 values in this column are also not used in no mode. The ones that are used in no mode, because they affect the anti-collision dialog, are the minimum center to center, minimum center to center to lease line, and minimum separation factor. And these are effectively your absolute limits, the no-go limits. So for example, right now we've got our center to center distance on 2 of our offsets is 16.24 feet. If I change the minimum center to center to 20 foot, you'll see now that those are highlighted in red, and we've got a warning flag that's flashing telling us that we've exceeded our anti-collision center to center distance based upon our bit projection. Okay, so this isn't based upon our survey, this is based upon our bit projection, and as such this can inform us in advance when we are likely to exceed anti-collision settings that we've set up here. I'll change that back to 15. And our separation factor here is 3.78. Again, it works in a similar way. If I change that to 4, we'll get an error, and it's based upon anti-collision separation factor. Okay, so this is how you set up the anti-collision limits within the DD dashboard. So that's basically the inputs that affect no mode. It's a very simple bit projection anti-collision setup. We're now going to go ahead and look at vertical mode. So if I check vertical mode, you'll notice now that instead of this being blank by default, we now have a distance from plan and a maximum inclination warning setting. And effectively this is based upon the logic for vertical mode. And this should be selected when you're in a vertical portion of the well and you're trying to stay on plan. You'll also notice that a lot of these titles have been highlighted in blue, and the ones highlighted in blue are the individual options that affect your current mode selection. So in this case, include rotary and projection, that affects vertical mode. Auto motor yield and auto rotary, they are also utilizable in vertical mode. Same with the rotary dogleg severity, rotary tool face, motor yield, default motor yield, and max vertical inclination. Max distance in vertical, max dogleg severity, minimum slide length, aggressiveness, projection distance 1, projection distance 2, and stand length. Okay, so all of these are important for our vertical mode. We've already discussed what include rotary and projection does. That utilizes these rotary dogleg severity and rotary tool face values in our projections if this is selected. Auto motor yield. If we have a slide sheet that already has slides in it and we have a survey record that covers that interval, then based upon that slide interval, the motor yield can automatically be calculated, and it will automatically update this motor yield cell here. So by default we've got in 6. if I check this box, and if our slide sheet had any slide intervals in it that were covered by a survey, it would then update this motor yield with what was actually achieved. Auto rotary works in the same way, in the fact that it will utilize the slide sheet to look for areas of rotary and the survey record. And based upon that, it will take the rotary dogleg severity and rotary tool face cells and update them based upon what has actually been achieved. Okay, so I'm going to just change these values to 0. And I'm going to select the auto rotary checkbox. And you can see now that these have updated to the values calculated based upon our slide sheet history and our survey data. Okay, so by checking these auto motor yield and auto rotary, we can use historical data from our actual interval that we've drilled, and then by including rotary in projection, we can estimate the rotary trends, and also if there's any sliding to be done, the lengths of those slides recommended will be more accurate based upon realistic motor yields that we've already achieved so far in this run. Max vertical inclination. So if we're in a vertical section, we may not want to exceed a particular inclination limit, and so this is where we can set that within the software. So this is effectively, if we start approaching this limit, we're more likely to receive a slide advisory to slide back to vertical before reaching this limit. Vertical max distance. This is directly represented on our tool face rows by this red circle here. So this is physically the radius from our plan that we are setting as a limit to not exceed. Okay, so if I change this to say 30, we'll see that our limitation here changes. And again, this will affect, if we're running slide advisories, when we get the trigger to slide or rotate ahead. So that is based upon our max vertical inclination and vertical max distance, i.e. how close are we to these thresholds, and if we're very close, we will probably get a slide advisory, and if we're a long way away from it, it's probably going to let us carry on and rotate ahead. So put that back to 15. And you can see now, based upon our vertical max distance, we've now gone from a rotate ahead directive to a slide directive because we're actually approaching, and based upon our projections, we're actually going to cross that vertical maximum distance. Okay, so the inputs you put in here will directly affect the outputs of our slide advisory that are created. Max dogleg severity. Again, this is the maximum dogleg severity that the slide advisory will recommend. Okay, so we can see here it's advising based upon a motor yield of 6, where we are in relation to the plan, our maximum inclination, our maximum distance we can be limits. It's said a 34 US foot slide on a 145 magnetic tool face, and this has been limited by our maximum dogleg severity, i.e. it would have advised a larger slide interval, but we would achieve greater than a 2-degree dogleg severity if we slid any further in this stand. If I change that max dogleg severity to a 3, for example, we can now see it's issuing a 50-foot slide. If I change it to a 6, it's still a 50-foot slide. So that is what we would actually need to achieve realistically to get back on plan if we were not limited by anything in terms of dogleg severity. Okay, so that's what the maximum dogleg severity does. It caps our slide recommendation distance so that we do not exceed a dogleg severity based upon our motor yield input. Minimum slide length. So if the software thinks that we need to make a slide, but the calculation says that it's a very small length of slide, say 2-3 foot, we can put in a limit here so that we don't receive really small nudge slides from the calculation. So if we didn't want to slide for an interval, say, of less than 10 foot, we could put in a 10-foot minimum slide interval. Now, the slide recommendations that we're receiving are 34 foot, and as such, they already exceed this minimum limit. If I change this to 40 foot, we would receive a rotate ahead directive, but with the proviso here of minimum slide in brackets, i.e. it wants to slide, but the slide directive that is calculated is less than the minimum slide length input here. Okay, if I change that back to 0, you will always see what the slide calculation directive is. Aggressiveness. This is sort of a coefficient that works in the background. This takes into account your max vertical inclination, your vertical max distance, and all of this other information. And it will have an effect on when a slide advisory is given or whether you're told to rotate ahead. So if I put the aggressiveness as, say, 0, we're given a rotate ahead directive. If I put it at 100, you're very likely to get very small, tweaky slide directives. Okay, so that is just how likely you are to receive a slide advisory based upon the variation from the max vertical inclination and max vertical distance. Our projection distance 1 and projection distance 2 directly affect these projection additions beyond our bit projection that you get in vertical mode. So right now they're set up as 1 and 200, but these could be 200 and 400 respectively, depending on what you wanted. In this case, I'm going to do 100 foot and 1,000 foot. I'm going to put that back to 100 and 200. And then stand length. So this is stand length that is being used in the slide advisory capacity to know how much room you've actually got to work within that stand. Again, as in any things that were effective in no mode are effective in all the other modes as well. So for example, our anti-collision setups are still utilizable in vertical mode. It should be noted that projection 1 and projection 2 will always be rotary projections. So based upon the rotary dogleg severity and rotary tool face that you have input here, and whether you've got this include rotary and projection checkbox checked, that will affect your projection distance 1 and projection distance 2 projections. I'm going to go on now and look at a curve mode example. Again, I'm going to open my survey, open my slide sheet, and you can see here we've got a load of slide intervals here, and then I go ahead and open up my directional drilling dashboard. We have a quick look at the 3D plot here. We can go ahead, zoom out a bit. We can see here in the red is our survey record, the blue points are the individual survey points, the green section here is our bit projection, and then the yellow here is our projection to landing point. You can see on the tool face rows here that we're looking like we're going to be about 15 foot left, 14.84, and 4.5 foot above our initial landing point based upon our current settings. So let's go and have a look at those settings. Double left click and it brings up our DD dashboard settings. Now at the top here, our landing target critical point selection. Now I've had this open before, I've already selected this point, but we're going to show you how you do that. This drop down menu takes your current principal plan and it has all of the critical points in that principal plan. So you select your landing point, it will update the coordinates from your principal plan, and it will put in the landing TBD, landing inc, and landing ASI values from that principal plan. If you hit find landing, it will also update that setting. So even if you had up here selected, you hit find landing, it will automatically look at your plan and try and pull in the most likely point in there in terms of TBD, inc, and ASI. Based upon that, you can see in the 3D plot and on our toolface rows where we are in relation to that landing point. Again, this being our landing point and this being our landing projection in terms of where the plan is. Okay, so unlike vertical mode, we've got some different inputs here that affect our curve mode calculations. We've still got auto motor yield affects it. We've still got auto motor yield, but now we have auto pick curve target. Now, what this does is, if that's unchecked, by default it uses the principal plan's landing point. And that will be very rigid in terms of trying to land off at the same TVD, inclination and azimuth as the plan. However, what we can see here is we're actually quite far off left and right. And in terms of measured depth, we're actually quite a long way out as well. So what auto pick curve target does is it tries to reduce the distance to land off, but maybe at the detriment of either an azimuth change or TVD. So let's just check that box now. We've seen here now it wants to land TVD deeper, and the azimuth won't be perfectly aligned with the azimuth that was in the original plan. So the inclination's good. The azimuth, we're going to be about 2 degrees further right than we originally planned, and TVD wise are going to be very, very close. So what we're looking at here is actually, in terms of our landing projection, it brings us closer to TVD and closer up, down, left, right than we were just working off the planned projection. Again, we are landing based upon where we are deeper down the plan. So it effectively gives you 2 methods of projecting onto your landing point. One, if you hit find landing based upon your plan only and hitting bang on that inclination and azimuth, and one based upon a adjusted TVD and azimuth, but will probably get you realistically closer to that landing point. So depending on what's more important to you, your inclination and azimuth or the physical distance from landing point, you have some variability of choosing your projection method there. Okay, so as we've already looked at, landing TVD, landing inc and landing ASI are the coordinates that are used in your landing projection. If I uncheck auto pick curve target, I can go ahead and change these values to whatever I like. This will update my 3D plot, and it will also update the tool face rows and the slide advisory based upon whatever the user inputs here. Okay, so you can see here that the software is using those coordinates as the basis for the projection methods and the slide advisories. Next, motor yield. So this directly affects, obviously, our curve projections and slide advisories. We currently have auto motor yield selected, so these will be actual motor yields calculated based upon our slide sheet and survey records. And the default motor yield is the motor yield used in the absence of a motor yield value here, i.e. a slide sheet that we don't have any slides that have been covered by a survey interval yet. That will be the value used prior to this being input. Max delta ASI. So this is the maximum delta azimuth that the software will allow in any of its slide recommendations or landing azimuth recommendations. So when we used auto pick curve target, it actually made just less than a 2 degree azimuth change difference in terms of landing point. So that's how much wiggle room effectively we've given the software to try and hit the landing point. If I change this to a 4, for example, it's going to take even more leeway, get us even closer to the target, but we're going to be even further out on azimuth when it comes to landing point. Okay, so that's what this max delta ASI does. Max dogleg severity is pretty self-evident. This will be the maximum dogleg severity that we can possibly use during the curve section. You will never receive a slide directive that exceeds that dogleg severity. And same as previous with the minimum slide length. you will not receive a slide directive under that particular length. So again, just to re-emphasize that, we've got a 14-foot slide directive currently. If I put in a 15-foot minimum, we will receive a rotator head that is being capped by the minimum slide distance. If I put that at 12, we will then receive our slide recommendation. And stand length in the curve. Effectively, this is the survey interval that you'll be taking. So the distance that you're actually going to drill before you stop and take another survey. And again, this will affect the slide recommendations that you receive, because if it's working off a 30-foot as opposed to a 100-foot stand, it will recommend shorter but more regular slides. So that covers the curve mode options and the effect that they have upon the projections and the slide advisories. Now go on to an example for using lateral mode. Okay, so we open up a survey, open up a slide sheet, and in this lateral section you can see we've got long periods of rotary and some sliding in there as well. And then you go ahead and open up the DD dashboard. Okay, we have an orange warning already triggered, and this is for max down approaching window bottom. Just going to suppress that now, and we'll come back to that in a moment. First visual obvious difference between lateral mode and others is the tolerance window here. So in vertical mode we had a circular window. In curve mode we didn't have a tolerance window, it was just trying to hit a landing point. And in lateral mode we either have a square or rectangular tolerance. So let's go and look at the settings. As I said before, lateral mode can be used in a lateral or in a tangent. And effectively what it tries to do is again keep you back on plan, but you have a square or rectangular tolerance to stay within. The warning levels are different here. Instead of working from a max distance from the center, you've got an up, down and left, right tolerance that we input. And we also work off a max difference from inclination and a max difference from azimuth on the plan. So the blue items that are important in the lateral mode setting is include rotary and projection. In this case we haven't got it turned on. Auto motor yield and auto rotary. The rotary dogleg severity, rotary tool face, motor yield and default motor yield settings. And then we have this max delta inc, max delta ASI. And these will limit what your directional recommendation will be from the slide advisory. They will also trigger warning alarms when these thresholds are being approached. Lateral up-down tolerance, lateral left-right tolerance are what make up this tolerance area here. So we have 100 foot total, which gives us a 50-foot right and a 50-foot left of plan window. Same for the up-down. So if, for example, in the left-right, I change that to 200, we'll see our window goes from a square to a rectangle. And again, 100 foot left, 100 foot right, 50 foot up, 50 foot down. Much like for our vertical mode, the slide advisory will be affected by the size and shape of this tolerance window that we set up. Also, we've got lateral tolerance offset up down, lateral tolerance offset left right. So in this circumstance, if we put the offset up down at 20, okay, what it's done is it's taken the same size of window, but it's shifted it by 20 down the way. Okay, so it was centered on the plan, and now it's moved it down by 20 foot. We can do the same thing with left-right. If I put 20 in left-right, it's shifted it 20 to the right. Okay, so that's how the offsets work. We've also got a max dogleg severity and a minimum slide length. Again, these will affect the slide advisory is given. Aggressiveness is also a slide advisory factor that we discussed in vertical mode. And again, much like in vertical mode, we've got projection distance 1, projection distance 2, and stand length, which will dictate the lengths of the projections, and the stand length will affect the slide advisory given. So those are the settings that affect the lateral mode, and again, it's pretty self-explanatory in terms of this is the settings that are used that affect the logic of the advisories given. So in this case, we have a bit projection in green here. It's very close to our bottom tolerance window. We currently have a azimuth of 150.5. If we look at our 3D plot, we can actually see that we are starting to head very much left of the line, but we're kind of holding off in inclination in terms of diverging from the plan. So it's actually giving us an advisory to steer right and up, which is what you would anticipate. It's wanting to converge back on the azimuth of the line here. Okay, so the issue here would be we'd actually be diverging from the plan wildly if we continued off on the azimuth that we're on. So that's the thing that is trying to alter here. And we can see here in pink, this is our slide advisory projection. So if we follow this slide advisory, that's where we'll end up. And the yellow here are our rotary projections at 100 and 200 foot. And because we have include rotary and projection turned off, these will be straight line projections based upon our current bit projection, inclination and azimuth. One item that was not covered in the initial settings overview was under settings, rig messages. So rig messages actually has two functions here. We've got the ability to force a slide directive. So if for whatever reason the personnel at the rig site disagree with the slide advisory given by the software, they can override that particular functionality there. So if they want to do that, they could go to force slide directive. They can specify the start depth of that slide directive or leave it blank to have it happen at current depth. And then they would put in a slide length and a tool face. Let's just put a tool face of 5 because that's the tool face to plan, for example. Okay, so right now our current slide directive is 12 foot on a 51 right. And we can see here our slide directive line here is on the 51 right line. If I hit send, slide directive sent, you could instantly see there the slide directive changes onto a 5 tool face, and we've got a updated slide length here. Now it's sometimes 1 foot difference in terms of what we actually input because of the rounding in numbers behind the scenes. And the tool face there will remain as per the original slide advisory tool face, to make you aware that this isn't actually an advisory, this is a manual override. So this will then take into effect your new forced slide directive. We also saw the projection based upon the advisory change to the new location. So that is how you would override an existing directive. Rig messages section is you can actually type in messages here, hit send, and that will get sent to the Innova web portal. So when people are looking on the dashboard window of the Innova portal, the person at the rig site can send messages, so they'll be viewed alongside the toolface rows and the drilling parameters on the Innova web portal. In order to undo a manual slide override, you can go back to your settings, double left click to get back to your settings, and you hit calculate recommendation again. This will run a whole new reset of the calculation for your slide directive, and it will go back to the software calculating your slide advisory instead of the manual override. So we're back to what we had before, a 12-foot slide on a 51 right tool face. So now that we've been through all the different modes of the DD dashboard, effectively you can use this as a tool just for viewing all the data in one place and getting a bit projection with the no mode, or depending on which particular part of your wellbore you're in, you can use a more intelligent advisory setup based upon vertical, curve, or lateral/tangent modes. So that is the basic summary of the Directional Driller's Dashboard within WellSeeker Pro. We're now going to go on to some questions and answers and then an exercise. During this questions section, we'll read out the question first, followed shortly after by the answer. If you don't know the answer immediately, pause the video, have a think about it. If not, refer back to the video to find out the answer before then continuing the video for the actual answer. So first question, what data sources affect the information displayed in the DD dashboard? The surveys, slide sheet, offset wells selected for that survey, principal plan, the BHA information in the drill string editor, the rig states dialog threshold settings, and the WITS/WITSML data, as well as inputs in the settings dialog, all affect the information displayed in the DD dashboard. So loads of different dialogues culminating in the results that you see in the DD dashboard. Second question, how is the bit projection depth in the DD dashboard calculated? The answer is it takes the deeper of the two of either the slide sheet end depth or the last survey depth plus the survey offset, whichever of those two is deepest. Next question. I have a number of offset wells selected for my survey, but I can't see them all in the dashboard anti-collision section. Why might this be? So in the DD dashboard settings dialog, there's an option limit AC display. If you have that checked, it will only display the offset wells that are deemed close enough to display. If you uncheck that, it will display all of your offset wells in an anti-collision section. Last question, what do the DD dashboard settings do? Okay, the DD dashboard settings allow the user to specify various options and values that affect the mode selection, projections, drilling advisories, and warnings that are calculated and displayed in the DD dashboard. Okay, next on to the exercise. So ideally the user should test this functionality using a real-world example, so something drilled in real time, preferably with WITS and WITSML real-time data feeds running as well, so you get the full benefit of the gauges, the real-time parameter data, the auto-populate functions for the slide sheet and the surveys as well. Okay, first of all, have a database with an actual well, a completed BHA in the drill string editor, and a survey under that actual well. Then go ahead and open up the slide sheet dialog for that survey, and open up the DD dashboard. Change the layout, gauge, and drilling parameter settings as you want them set up. Then go ahead and open the settings dialog within the DD dashboard and select appropriate settings for the portion of the well that you're currently drilling. If you're using WITS or WITSML, set up the rig states and auto-populate the slide sheets and surveys. If not, just manually input the slide sheet data and the surveys as well. As you're going through this well in real time, observe the DD dashboard and all its displayed data. Become familiar with all the features that are on there. So the best way of getting a handle of this is actually physically using it. Seeing all the options that come around, watching what's calculated and displayed, figuring out why it's calculated that way, and what options that you've input or settings that you've selected that affect that. Okay, and then last thing, alter the mode and settings based on the section of the well design you are currently drilling. And again, just become familiar with all the nuances of the settings that you're changing and how that affects what's displayed on the screen, the slide advisories you're given, the projections that you have in place. If at any point you become stuck, refer back to the video that we've just watched for a refresher to find out the answer to your question. That concludes the Directional Drilling Dashboard training for WellSeeker Pro.